Tēnā koutou katoa. Good evening, ladies and gentlemen. My name is Gary Wilson, the Deputy Vice-Chancellor for Research here at the University of Waikato. I am thrilled to be here. This is a really important evening in our calendar, it always is, as we gather to celebrate the academic journey of one of our professors, and in this case, Nihal Kularatna. I will just, by way of a few words, introduce Nihal and the lecture, and then invite him to the stage. Dr. Nihal Kularatna earned his honours degree in electrical engineering from the University of Ceylon in 1976. He spent the next 25 years as a practising electronic engineer, gaining extensive experience in aviation ground electronics, digital telecommunications, industrial systems and power electronics. In 1999, he was appointed CEO of the Arthur C. Clarke Institute for Modern Technologies, a role he held until 2001. In 2002, Dr. Kularatna transitioned to academia, accepting a position as senior lecturer in the Department of Electrical and Computer Engineering at the University of Auckland. He later joined the University of Waikato in 2006. His contribution to engineering innovation were recognised when he was named New Zealand Engineering Innovator of the Year in 2013. In 2015, he became the first recipient of the Doctor of Science in Engineering from the University of Waikato. Dr. Kularatna is the author of 10 authoritative reference books in electronic engineering, published by leading global publishers, including the IET in London and Elsevier in the USA. His books cover diverse areas such as instrumentation, circuit design, power electronics, telecommunications, energy storage, and transient surge protection, with several titles reaching new editions and reprints in the US and the UK. In addition, he has published over 200 research papers and industry-focused articles. No mean feat. At the University of Waikato, he has supervised more than a dozen PhD students and an equal number of master's students, earning the university's Postgraduate Research Supervision Staff Excellence Award in 2021. His current research interests include supercapacitor applications, power converter design, and protection strategies for renewable energy systems. And I think we're going to learn more about that tonight. Internationally recognised for pioneering the Supercapacitor Assisted SCA technology and developing the SCA loss management theory. Dr. Kularatna is a sought-after speaker. He regularly presents invited tutorials and workshops at IEEE conferences and for industry, with recent engagements in cities including Atlanta, Chicago, South Carolina, Nagasaki, and Shanghai, and tonight, Hamilton. Outside his professional work, Dr. Kularatna enjoys gardening and car grooming, although I don't know how he has time. But with that, please join me in welcoming tonight's speaker, Professor Nihal Kularatna, to the stage.
Tēnā koutou katoa. Thank you so much, Professor Gary Wilson, for introducing me. So I'm just going to present my professional life journey, starting in 1972 at the Faculty of Engineering, University of Waikato, Sri Lanka. So in 1972, I got the entry into the School of Engineering, getting through the competitive A-level examination as the only child of a poor Sri Lankan southern family. Not for the free education, I wouldn't have had an opportunity to become a qualified engineer. So this was a very beautiful surrounding, similar, more or less similar to Waikato University in the upcountry area of Sri Lanka. So I was taught by very many good academics who always said, apply the theory you learn in these subjects in real world. So I strongly believed that and try to practice it from the first year onwards. So it was a time, there was a revolution of technology in electronics in the early 1970s. I remember as a school child, and when I was about to enter the university, my house had a vacuum tube radio like that, where I used to look from the backside to see the glowing filaments of the valves, which I enjoyed. I didn't understand how things worked at that time. But when I was entering the university in 1972, these bulky vacuum tube radios were getting converted to portable transistor radios. So owning one of them was a privilege for most families in countries like Sri Lanka because they were new technology. So a story about the technology. Electronics requires amplifiers and kind of switches and so on. In 1950s to 70s, you had only vacuum tubes, which was bulky, brittle, and required high voltages, and they were very unsafe because they were using several hundred volts power supplies, etc. But all that got changed when three great engineers of the Bell Labs, Bardeen, Shockley, and Brattain, invented the transistor in 1947 in their research. So these people won the Nobel Prize for physics for the invention of the transistor. One of them, Bardeen, became one of the only person in the world to win the Nobel Prize for physics twice. So when I was in the university, early versions of transistors and integrated circuits were coming into our course material. So first amplifiers we used as op-amps were things like that, MU-A709 in our courses. So the first 4-bit microprocessor was commercially available only in 1971. So we didn't have the opportunity to play with these microprocessors because the 8-bit processor was coming only at the end of 72, by which time we were moving to third, fourth years of the course, so people didn't have time to put this into these things. But I enjoyed electronics as a young undergraduate, partly as a student, partly as a hobbyist. So I used to collect these latest bits and pieces of stereo amplifiers, audio amplifiers, multimeter kits, etc., and played with them, built and enjoyed. But at the early days, I didn't understand how the circuits properly work. But as I was going into the third, fourth years, I was able to understand how things work. And then I thought, rather than using other people's parts, can I develop my own circuits and systems as a design engineer? During this time, computers we had in the university were IBM 1130s, where to input the program into the computer, you had to use a punch card. So students were not allowed into the computer rooms. We could see the computer only through 3 glass partitions. Nothing, we can't go close to the computer at all. But the power of those computers you had those days is almost probably 1 million times smaller than the processors we use in our cell phones today. So I finished my undergraduate course in 1976. I enjoyed all my electronics and affiliated subjects. At the same time, I enjoyed the beautiful surroundings of University of Peradeniya and the time in the university. So I was lucky to get a graduate engineer position in the Department of Civil Aviation late 1976, where there was a new project beginning with UNDP funding for navigational aid upgrade of the entire air navigation region of Sri Lanka. So I was just a 21 years plus engineer. I was asked to take the entire responsibility of installing this about $1 million piece of equipment with the support of many technical staff and other people traveling into various corners of the island to install and commission and flight calibrate these things. So we were very lucky as fresh graduates, where we were given training in UK, USA, France, and all these places. So my first travel for training was to Bletchley Park in Milton Keynes, which was, I think, dedicated to Turing, the famous engineer. So I was at the Civil Aviation Authority Training School taking my first courses on digital techniques and the microprocessor techniques. Then, at the end of that training, my department had organized me to travel to USA, Federal Aviation Academy Navigation Aid School, to learn about the instruments I'm going to install, these things called VORDME, VHF Omni Range, and the distance measuring equipment, which gives the aircrafts the directions and the distance up to about 250 nautical miles. So I was the sole engineer to be in charge of all these things. By the time I was finishing about 6 years in this organization, I was becoming an expert on installation commissioning of VORDMEs, and every equipment I tackled, I understood how the theory works in every single block inside. So one of the additional courses I got in Milton Keynes, Bletchley Park, at Civil Aviation Authority Training School was an instrumentation course, which told me how to develop a very good training program in instrumentation and measurement for practicing engineers, which I later on developed in my later times of the job. So, because of my hobby interest, I thought, why not I develop a home lab? Starting with the DC power supply, because I could not afford even to buy a multimeter, because my salary I got from airport job was not enough to think of anything like this. So I thought I will start from transistors and diodes and basic components. I design, build, and test my laboratory power supply, which can work like a professional power supply you can buy. So what was the reference point for me? In the university, I had Hewlett-Packard DC power supplies, which was supposed to be the best power supplies those days for the labs, because this had the best protection system called fallback protection. So what I did was, with my continuing hobby interest, I changed myself to a designer hobbyist. I want to design from basic fundamentals and building blocks and testing circuits. So to develop my home lab, I used this power supply as a reference point. I wanted to do with minimum amount of transistors, because then it is the cheapest possible and easy to build. But I want to add fallback protection, which was unique to this Hewlett-Packard power supply. So my first real-world design of this laboratory power supply, I struggled for about 4 months to complete the basic design, which worked. It can work as an adjustable laboratory power supply. But I didn't want to stop from there. I thought if I had fallback protection like in the Hewlett-Packard power supplies, I had done something much better. How do I do it? I don't know. textbooks never told us how to do things like this, because these things were like company secrets of how to do it. But some other they figured out, Hewlett-Packard adds few more transistors to the existing circuit to activate this protection. So, to add this protection, I went on various design directions, nothing worked. I was getting very frustrated after about 3-4 months. So every time I was doing something else, my mind was going back to how do you design this fallback technique. So one day, when I was traveling in a late night bus from down south, one town to my home back, I had free time to fall into a meditation to think, is there another way of trying this circuit? Then suddenly I got an idea with a very simple Zener diode, which nobody has tried it to my knowledge. So I went home at 11 o'clock, worked, had my dinner, worked till 3 in the morning. My fallback protection was working because with one good thing, because I didn't use any additional transistors like Hewlett-Packard. So then I thought, hey, why not? This may be a very unique circuit. How do you know? Because I'm a third world engineer. I just get only some British and American magazines to read about latest developments of technology. Good old days, no Google, no internet, nothing. So only thing I had positive thinking, pushing the design boundaries. So I ultimately searched about 2 years back copies of American electronics and British electronic engineering to see such a design technique has been ever published by any engineer in the world. So my ultimate conclusion was nobody has tried this. So then I thought, hey, why not I test whether I have done something unique by writing a paper about my little circuit, 6 transistors plus few other components. So I drafted an article for the section called Applied Ideas of the Electronic Engineering magazine, published by Morgan Grampian Publishers in UK. So I thought if I post this from Sri Lanka, they will not even open it, they will put it in the bin. What is this third world guy who is going to tell us how to publish an idea? So I decided to write the best version of English in it, but my English was very bad at that time. So what I did was I had a very good civil engineering colleague of mine, Mohan Kumaraswamy, who was a civil engineer working as a graduate engineer in Petroleum Corporation. So I called him, Mohan, I want some help from you. Please, I'm bringing an article written by me in Nihal's Electronics is in bad English of Nihal. So I said, I want to convert this to Mohan's English, because his English was so good. So he sat with me in his office for nearly 2 hours. He edited my article to a very nice edited form with no errors, very nice reading, all that. So I did this whole exercise because it was just about the time I was about to travel for my first training in Milton Keynes, UK, and then to US. So I took this article, all set, and posted it with my uncle's address in London to the publishing editor. So then after that, I went to US for 5 months of my NavAids training. When I came back for another training in UK, my father's brother, he brought a letter to me and said, Nihal, congratulations, that article is accepted by the magazine. Here is the letter, they want you to sign the copyright and send it back, then they will publish it. So when I was just 23 plus years old, my first paper gets published in the British Electronic Engineering Journal with no supervisors, because I was my own guide. So this got published. The interesting thing was, when they said, when you sign the copyright and we get this published, you will be paid an honorarium of 20 sterling pounds, which was 1.5 times of my monthly salary in aviation. So this gave me a very big motivation to design more circuits now, because now I feel, okay, I have got a page in this British magazine. It's wonderful. I was very motivated. Then I was working for this UNDP project with the UNDP appointed very experienced navigational aid engineer as our project director. I went and showed him the published magazine. He stood up, congratulated me and said, Nihal, next time if you develop any further circuits, do not publish in the British magazine only. You try to go to American industry magazines. So I did few more developments to the same circuit. I got 2 more papers. So actually, Mohan, who edited this one, I'm just showing him because he later on became a very well-known professor in civil engineering in Hong Kong University. So always I tell Mohan, you made me publish with good writing, how to do good writing, you taught me how to do it. So my further publications appeared in American McGraw-Hill Electronics, where in 1965, the famous Moore's Law was published. So even these articles gave me $50 each, which was once again comparable with my monthly salary. But all these things kept me think of publishing. So my aviation career, at the end of about 5th year, I got married. I wanted to start a family. I wanted to build a house. My salary was not enough. I decided, okay, I'll quit this job. I will go to Middle East and sign a contract for 3 years. And I went to Saudi Arabia, started working as a telecommunications engineer, but my aviation ground electronics experience on all-day digital computers, navigational aids, communication systems, all that made my life very easy in Saudi Arabia because I could handle any electronic system. When they fail, I can go and fix it. So during this time, my salary was reasonable. I had flexibility. So I kept ordering books for learning more about electronic design. So this is one of the books I ordered in 1982 to learn more. So then when I was browsing through this book, there was a section on power supplies. I browsed through these things. When I went to 341st page, oh my gosh, my article is published by these people with my name there. So what a pleasant shock was that. So I kept doing these things, and at the end of 1980, third year, mid of 1985, I returned to the country. I was looking for a job. Then somebody said, in honor of Sir Arthur C. Clarke, godfather of satellite communications, there's a new institute formed. They are looking for practicing engineers and researchers. You may have a chance. So I sent a brief application with my background. So I was called for an interview by the director, who was coming from America. He was a professor of chemistry from Maryland University, Professor Cyril Ponamperuma. So he interviewed me in mid-August. He gave me the job moment he saw these past publications. So I became R&D engineer, and within 2 days I was working in Arthur C. Clarke Institute. So I started in August 1985, continued for 16 plus years. 1990 I became a principal engineer, managing a lot of research projects, labs, training programs, developing the institute. And so I was enjoying my technical work, but I was keeping a focus. What was my focus? Whatever I do in Sri Lanka, my measure of success is at the international norm. So that gave me a very good satisfaction of what I did, and by 1999 I was appointed as the first full-time chief executive of the Clarke Institute by a government decision with a special package for me. So during this time, my home lab was still working. Around 1985, when I was building my house in the end of a lane, my 230 volts AC mains was going down to 160 volts around 7 p.m. None of the commercial products were working. So I thought I will invent a product. I'll build a product. So I started patiently with this in my home lab. Some young engineers who were working at Clarke Institute and elsewhere, they came and helped me to learn from me. So we developed this 1 kilowatt prototype, and we wanted to once again test our innovative circuit. So I wrote an article to the famous Power Conversion and Intelligent Motion magazine of US. So they gave me a 5-page feature article for my technique in May 1988. So once again, my home lab resulted in a very good publication and recognition for my work. So during Clarke Institute times, I was developing my own career by helping the institute to develop its own prestige and the capabilities as a national institute. So I helped them develop labs, research labs, test labs, industry-oriented research projects, CPD courses for the industry. I developed 12 CPD courses for the practicing engineers, practicing electronics engineers in the country, which were becoming very popular. So we earned a lot of money for the institute by these things. Youth training programs, school leavers, school children. Then most of what we did, we tried to publish overseas, not in Sri Lanka. The activities we did as research, training, everything, we wanted to do it as self-financing activity. Ultimately, by the time I was becoming the chief executive, 20% of the recurrent expenditure of the Clarke Institute given by the government, we earned from our research and training programs. So actually during this time, I was inspired by the godfather of satellite communications, Arthur C. Clarke, and he introduced me a very famous Bell Lab engineer, Professor John Robinson Pierce, who named the transistor when these 3 guys in Bell Labs invented the transistor. So he became my mentor. He told me he gave me a lot of advice. I'll have 2 slides dedicated for these 2 people later. So I was traveling for many conferences. I always made side trips to visit Silicon Valley companies, instrument companies like Tektronix, Hewlett-Packard, Fluke. I have met all the design engineers, asked them, how do you design this oscilloscope? How do you design this multimeter? Why is it different from this multimeter to this one? So I was asking a lot of questions from them. They were very helpful. So I traveled a lot. So with this exposure to the US industry, I was able to develop these courses to a level that every course material was good enough for a reference book published for practicing engineers like these things. We were published about 5 books: power electronics, instrumentation, circuit design, telecommunications, all that. So I get a lot of contracts because these 2 people helped me how to go on this path of writing books, etc. So by the end of 1999, when I was promoted to the CEO of the ACCIMT, I had to take a management hat, and I was to get away from the labs and trainings. I didn't like too much, but I was given the challenge of bringing the institute to an international level. I thought, okay, I'll do it. So about Sir Arthur Clarke, he published the first Wireless World article in 1945 predicting that you can place 3 satellites on the 20,000 mile circle on the geostationary orbit. That will be good enough to have international telecommunication across countries. So for that reason, he is considered the godfather of satellite communications. He was very much helpful for my work. He always supported me with sometimes getting funds from America, etc., for my travels, conferences, registrations. So I had no problem of traveling and doing these things. Then, actually, the Arthur C. Clarke Institute was developed. What Arthur won the Marconi Award in 1982 or 83. The $25,000 or $50,000 he earned from that award, he gave it to the Sri Lankan government to put up the first building of Arthur C. Clarke Institute. So that is where we were having our early offices in 85, 86 like. So I was very lucky. After I was becoming the director in year 2000, for my birthday, Arthur C. Clarke agreed to come and honor us in our humble house for my birthday. So it's a good memory today. So about Professor John Pierce, who was helping me. Okay, let me start with, what do you mean by transistor? Transfer resistor. Combining these two words, transistor came up. So John Pierce told me he was met by these three people after the transistor was invented. They asked, how do we give a name for this device which has these properties? He looked at the vacuum tube, which had the property called transconductance. But transistor has transresistance, opposite of that. So he said, this is transistor. So he became my advisor and the mentor for most of my work at the Clarke Institute. When I wanted to do my first book on instrumentation, at a Palo Alto, Silicon Valley area restaurant, he and his wife took me out for a dinner and asked me, what do you want as help? I said, I'm trying to convert my first successful course on instrumentation to a book published in either America or England. So he said, okay. He had written 25 books. By that time, he was 75 years old, I'm 35 years old. So he told me, he gave me the best advice. First advice, do not start any project or a book project, research project, if you cannot explain the entire project in a single sentence which can be understood by any layman. If you cannot do that, don't start that project. It will not be a success. So even today, in every PhD project I supervise, I practice this best advice I got from him. So his second one was, if you are starting your first book, you will be rejected by many publishers. Don't get disheartened. So this is about him. Actually, he is the person who joined two other people, including Shannon, to come up with the first paper on pulse code modulation, which is the underlying transmission system of the digital communication systems across the world. So, during the Arthur Clarke Institute times, with my conference travels extended to visit industries, etc., went well. So I was once sent out by Arthur C. Clarke's arrangement to visit ComSat Labs as a visitor of the president of the ComSat Labs, because president of ComSat Labs was a good friend of Arthur Clarke because of his satellite, these things. So I went there, ComSat Labs, and then one day I was visiting Dr. Yuko, director of the Intelsat. So once I finished my morning meeting with Yuko, Arthur's good friend, Dr. Fred Durant, he is one of the key people who developed the Smithsonian Institute of United States, Smithsonian Museum, right? He said, Nihal, I'm taking you out for lunch. Do you know where I'm taking you? No, I said, I don't know, Fred. He said, I'm taking you to Cosmos Club in Washington, D.C. Do you know what it is? No, I didn't know. Then he drove me to Cosmos Club. When he was sitting with me for the lunch, he said, this is the most elite club in Washington, D.C., where every US president is a member, every chief of armed services is a member. So I am a member. So now I had the privilege of sitting with him and having some lunch. So I was very lucky. So during this time, I did a lot of consultancy work for overseas places also, including Gartner Group, Technology Dynamics of New Jersey, who are developing UPSs, DC power supplies, etc. So industry publications of mine during ACC IMT times are very many. So my side trips to Silicon Valley companies like Analog Devices, Texas, and various other things showed me how these silicon ICs are developed, designed, and gone into mass-scale fabrication. So I learned a lot of things from these practicing engineers in the US. So my design, during one of my conferences in 1999, I presented a paper on one of my design techniques. At the end of my presentation, a gentleman called Aaron Levy came to me and said, Nihal, I have listened to many of your past presentations and this year also. Can you do a particular power converter design for me as a consultancy assignment? I said, what is it? I want a 1 kilowatt or 2 kilowatt DC-DC converter with this complete package of 6 centimeters by 9 centimeters to be packaged. Don't ask me the application. I won't tell you. If you can do it, I'll pay you. So I accepted the challenge from Aaron, and I did this once again in my home lab, employing another young graduate engineer from same school. I trained him how to become a design engineer. So in 2000, I decided to move to New Zealand. So my interest in most of these side projects were getting lost because I was the management chief of the institute, so I didn't have time to do it. So this project became a lost memory for me. But though I gave him the complete working circuit with all the measurements to show that it is doing the specifications he gave me. So once again, after I moved to Waikato, I went for a conference, APEC. There at the trade show, somebody comes and tapping at my shoulder and says, Nihal, do you remember me? Oh my gosh, this is Aaron Levy. Then we had fallen into a conversation at a coffee. I asked, what did you do with that circuit we designed? Did you use it? Yes, didn't I tell you? We convert that to a thick film hybrid manufactured by a Taiwan company. All those things are in part of a UPS we supplied for US naval submarines. My gosh. This was another shock for me because I never expected that to happen because this was done in a home lab. This was ending up in US naval submarines. So this is the circuit I designed exactly to his specifications within the time he gave me. So my home electronics lab was giving a lot of opportunities to young people in Sri Lanka who didn't have the luck of entering the engineering schools because of the competition. So some of them did Council of Engineering exams, etc., to become an engineer. So I gave a lot of projects for these people in my home lab, and they became I had a lot of consultancy work happening, so I took them to help me in the consultancies, and I trained them how to do big projects, big diagnostic exercises, fixing large industrial systems, etc. So most of these people did their CEI projects, like our fourth-year undergraduate projects, to do various products and tried their reports. So in this figure, this boy, his name is Sampath, I converted him to an aviation ground electronics engineer once again as a nav-aid engineer like me in good old days. So unfortunately, at the age of 52, he died of cancer, so that's why I dedicate this slide for him. So most of the work I did in my home lab were helping me to write books on circuit design, power management, etc. So one of the AC regulators I did there, later in a PhD project here became a US patent. So, okay, that's my Sri Lankan story. Now back to New Zealand. In 2000, Auckland University offering me a senior lecturer's position with 4 return tickets to my family, we ended up in Auckland. So Professor John T. Boyce, who was the head and department chairman at that time, he was the one who offered me this opportunity to become a senior lecturer. Because have I done a master's? Have I done a PhD? No. But my industry experience, he recognized. So when I was traveling from Sri Lanka to New Zealand to accept this job, I had some early versions of supercapacitors. I'll tell you what supercapacitors in a minute, showing a couple of demos. So this package was in my bag. I took it to the office and I thought, can I do something innovative with this? What can I do? Everybody uses this as replacement for batteries or supplementing batteries and so on. So can I do something different from that? So I gave a first undergraduate project to these 2 boys, Dulipa and I suddenly forget his name. So Tushita, right, thank you. So they did the project well. They showed me that supercapacitors can absorb transient surge. So ultimately, in 2006, I moved here. I didn't think of writing a paper, but my second supervisor, these 2 boys, he wrote a paper with my name and their names. This is our first publication on supercapacitors, written by the corresponding author, Udaya Madavala. Dulip is an associate prof in Auckland University now. So I kept asking what supercapacitors could do, right? Now, supercapacitors, okay, I'm not going to show you a magic show. This is a typical battery cell used in an electric vehicle-like thing. So this is 40 ampere hours, 2.3 ampere hours. This is about 80 watt hours. So this is a proper lithium battery. Now, these things have high energy density, but supercapacitors of similar volume, they can also store energy, but not that much. So when we started this project, these electrical double-layer supercapacitors were coming into the market with 3,000 farads and large values at a reasonable price. So we thought we'll use this in some innovative way. So did we know what it was? No, we tried. We took the risk. So then, this is a normal capacitor, about 5,600 microfarads. This about 3,000 farads, 1 million times larger capacitance in the same volume. So now, with the years of development, this 3,000 farad capacitor now has become a 100,000 farad capacitor. This has the energy, half of the energy like that lithium-ion battery. So batteries go and try to get adopted with supercapacitor advantage of long life, 500,000 to 1 million life cycle. So they are fit and forget in renewable energy things. So now this 3,000 farad in the new technology, now these 4,600 farads. So these are basically like batteries. Okay, now while I'm just trying to talk about cars and the use of supercapacitors, let me show you something which we did for the first year project. Okay, this is a batteryless solar car. No batteries here. My solar is simulated by the lamp. That is the car. So let it charge for a couple of minutes while I keep talking. That's a toy car. Here is a fancy car. Lamborghini Sian, 805 horsepower, 602 kilowatts, maximum speed of 355 kilometers per hour. 0 to 100 acceleration less than 2.8 seconds. How do they do it? They have a V12 petrol engine, but from 0 to 120 kilometers speed up is based on an electric motor, 48 electric motor coupled to the gearbox powered by a supercapacitor module. So from 0 to 120 you speed up with the electric drive based on supercapacitors, then the V12 engine kicks in to do the rest of the speed. So yes, in fancy cars you have supercapacitor. In our everyday modern cars, there are small supercapacitor modules for re-cranking the engine when you drive on the eco mode. So what you see on the right-hand side of the figure are commercial supercapacitor modules, coal season truck starters, car applications, wind energy applications, etc. Okay, now I moved to Waikato at the end of 2005, beginning my work in 2006. So I wanted to develop my own research area in energy storage, but in a different way. I was thinking battery supercapacitors. I thought no batteries in any one of my projects, so only supercapacitors. Did I take a risk? Yes, a significant risk. I didn't care, so I thought, yes, you have to take a risk in research if you want to be successful. So I got my first 2 PhD students. Sisira James is in the audience. This lady, she's now an associate professor in UTS Sydney. So they came as my first 2 PhD students. Sisira started doing transient surge propagation analysis inside surge protectors. This lady was given the task of developing a DC-DC converter based on supercapacitors. What made us do that? During that time, Waikato Link was very active with the researchers in the science and engineering schools. They had the Kivinet grant to have a competition for grants where you can tell them, we'll file some international patents. So if you can prove that you can file international patents, they organize us the grant. So I got 2 grants of that kind. So when I got my first grant, I got one of the very enthusiastic young person, Jayathu Fernando. He is in the audience, Jayathu. So I gave him a research engineer's job. He worked with me, and we did some simple experiments with existing linear regulators and supercapacitors. We came up with a very new technique called supercapacitor assisted low dropout regulator, for which a US patent was granted in 2011. So, with our success on the DC-DC converter, I thought, can supercapacitors be used in lightning surge protectors? Because I come from an equatorial country where during the monsoon times, lightning is severe. Every electronic thing, your televisions, computers, everything gets damaged. No surge protector commercially available is guaranteedly protecting them. So during this time, Sisira and myself, we were developing a surge test lab. We got another Waikato Link Kivinet grant to develop a surge protector basic idea which is implementable. So Jayathu came back again in 2009. He started developing the fundamental concept of our transient surge protector, now known as supercapacitor assisted surge protector. So by 2011, our surge lab was fully operational with several surge simulators, very expensive test gear, thanks to the university giving us this money. So I started developing more PhD projects. Even from that time to today, almost in all my PhD projects, my physics colleague, Alistair Stein-Ross, I know you are in the audience somewhere, he became the second supervisor of all my projects, because I'm just a design engineer, bull in a china shop, but he's a very meticulous analytical engineer. So whenever we had a successful technique completed, he takes the experimental results of my students, do simulation analysis, and match the experimental results to theory. So once these things match, we get a lot of journal publications. So with this work, in 2011, we published the first IEEE journal paper proving that supercapacitors can absorb lightning-like transients and survive. So we extended this to a PhD project by Jayathu Fernando, later coming as a PhD student. I know he's in the audience, to develop a protector called SCASA. So we filed a couple of patents, and we kept searching for commercial opportunities. Our Waikato link was very active those days. The young people in the Waikato link, very nice, they did a lot of hard work. So they were searching for regional people, international companies, and so on. Then they told me there is a company in Perth called Thor Technologies who are developing these kinds of things. So I'm very happy to see George Foster Jones, managing director and owner of the company, coming all the way from Perth to participate in this ceremony. Thank you, George. So I had a conference traveling thing, so I forgot now. See, this supercapacitor pack, which works instead of the batteries, is charged from the lamp. So I'm going to knock this off. See, that keeps running for circles and circles. No batteries here. All right, okay. Yeah. Okay, so I traveled to IECon 2012, and Waikato Link arranged a side trip for me to visit George's company, Thor Technologies. I had a half-day meeting. I told, this is what we do. George got convinced. Within 2 weeks, he came back to New Zealand to see what we do and what our labs are. So we developed a commercial version of that one for his company, this one, called Smart TV IQ2. So that was commercialized in 2014, and he gave me a pleasant surprise when I was telling him about this event, that in their Prodigy series of new surge protectors, this is one of the books we released based on our expertise we developed by developing surge protectors. So now he tells me that in this entire Prodigy family, all these products carry our technique, patented. Right? So I'm very glad to see some commercial operation in Australia is believing us and converting our techniques to these things. So in this trip, I show George what we do as a lot of additional projects. I'm sure we'll be able to do some more work with him. Thank you, George, once again. Right, so our SCAR techniques made me win the New Zealand Engineering Innovator of the Year. What are our SCAR techniques? Supercapacitor, SCALDO, SCASA, 5 PhDs, 2 PhDs, SCATMA for the hot water delay in our taps, SCARLET, SCAR white goods, SCAR inverter, these are ongoing, SCAR DC circuit breaker. So we developed a whole family of supercapacitor assisted techniques from nowhere. So our first technique, SCALDO, thanks to University Strategic Investment Grant in 2017 at Dr. Bruce Clarkson's time as the Dean, we got a $40,000 grant, and we worked with Southampton University's Professor Bill Redmond White to come up with the first silicon implementation of our SCALDO technique. So probably we are the only group in New Zealand to develop our own technique, get a patent, and then even convert that to silicon implementation. So now for all these things, we realized, oh, there is one common theory called SCALOM, Supercapacitor Assisted Loss Management Theory. So we published this theory derived from our practical development projects of these techniques. So for water heating project, Renai New Zealand came and worked with us. Because once again, I think QNet grant was giving us money. So we got a New Zealand patent for that again. So PhD completions by 2016. Shishira James, Tilini Vikramasinghe, she's working for Infineon Technologies in Austria. Kosala in UTS, Australia. Peter Lian working for Lowtech as the engineering manager. Jayatu for APL systems in Cambridge. Nikolai as a head of electrical in one of the private universities in Sri Lanka. So our industry partnerships with Thor, Renai, AECS, Hastings, Gallagher, ABB Napier, etc. So employment of our students, Sydney University, AUT, Infineon, Lowtech, APL Group, Sri Lankan institutions. So some of the work we did, we converted to some reference books in electronic engineering. So I'm going to give you 2 minutes lesson on electrical circuits, AC versus DC. What is AC? Electrons flow in both directions in a circuit, having variation of sinusoid in time, which was promoted by Tesla. But in modern equipment, when you are AC, in all our systems, we convert to DC with the first stage of what we call the rectifier. So, good old days, Edison was trying to develop DC systems, but he failed because Tesla was a better marketeer. So, but today with solar and wind and batteries, supercapacitor, everything coming with DC, so DC circuits are now becoming the future opportunity for sustainability. Why? Because less converters. So electrical systems deal with only 2 signals, voltage and current. Voltage is like a water tank's height. Current is like a water flow rate in liters per minute, which is equivalent to coulombs per second, which is amperes. So I'm trying to tell these school children, Ohm's law is not V equals IR. Ohm's law begins with that simple explanation. But school teachers don't do that, unfortunately. So they come with just a mathematical formula without understanding anything. So what is supercapacitor loss management theory? It's basically, in all systems, we have 3 basic types called resistors, capacitors, and inductors. When you pair a resistor and a capacitor, we form a resistor-capacitor circuit, where resistor part wastes energy. Capacitor stores energy. So our team worked with not the normal capacitor, giant capacitors called supercapacitors. So once you put supercapacitors and resistor be replaced by a resistive useful load like a heater, converter, inverter, DC-DC converter, anything, the wasted energy in the typical resistor is now transferred to the useful energy in the resistive load. So this is our SCALOM theory, because common physics, electrical physics undergraduate theory of RC circuit is basically massaged to accept a million order bigger capacitor, resistor be added by a useful resistor for consuming the wasteful energy in the circuit. So this is our SCALOM theory. So we published this one in 2021 in a journal paper. So now a lot of people who work on the energy storage, renewable area, they have started reading these things. So we had, with our team's humble beginning with supercapacitor assisted techniques, we have even come up with a new theory. So I'm not a theoretician, but basic theory, you don't need a lot of mathematical analysis and big formulas. It is fundamental thinking. So, okay, my next set of PhD students, Dilini, who developed the Scarlet technique. Thank you for coming from Napier for this event. Sadish, now a lecturer in AUT, he developed the magnetics part of SCASA, our surge protector technique. Tilanga, who works for our Kias Aerospace, he works on the high power Scaldo. Today he tells me his boss is the first New Zealander who went to space. Great to hear that. Nimesha, she developed the AC regulator technique with me. She was employed by Robotics Plus in Tauranga. Later on, she moved to Enatel and NFS company in Christchurch. So, thank you for all of you coming. So, our industry relations, Ports of Auckland, Thor, Worth Electronic Germany. Actually, Worth Electronics, which is a 65,000 employee, large German company, they have a well-developed lab set. So they have said, for your team, all our labs are freely open. In fact, we sent one of my current PhD students, Chamila, for a 3 weeks training in EMC labs to test our Scaldo techniques EMC compatibility. So we have these things open. Then Switzerland, the world's largest DC circuit breaker company, Sekiron. When we said we had developed this successful technique, their R&D chief, Dr. Lamara Tarek, visited us here. He looked at our what developed. So my present PhD student, Chamara, we were able to send him out to their company for a month's visit. So in 2 weeks there, he solved an outstanding problem which they couldn't solve for about 2 years of a detector circuit for a DC circuit breaker. So we have a lot of labs developed, high voltage transient test lab, supercapacitor wet lab, DC solar DC test lab, etc. So Ports of Auckland Limited, in 2017 and 18, they gave us the opportunity to develop batteryless, solar-based, contain offices to be powered by supercapacitor assisted converter. So we demonstrated it's doable. So they opened that on the Ports Open Day in 2017 and 18, they displayed that to public in Auckland. So we got 2 more books on these experiences. They were all published as a team now with PhD students, my co-supervisor, Professor Alistair Heinross, etc. So, okay, I won the Postgraduate Research Supervision Excellence Award in 2021. So, post-COVID, last 5 years, as the chief supervisor of 5 more PhD students, Chamara developing the supercapacitor DC circuit breaker. There is about 2 patents worth work he has done. DC refrigerator by Nirashi, inverter by supercapacitor inverter by Chamila, max joule capability supercapacitor SCASA by Randika, Calum, max Scaldo, high power Scaldo technique. So all these things are my ongoing things. Then with Dr. Marcus Wilson, I supervised as a second PhD supervisor for a supercapacitor high power pulse generator for brain excitation. So that was a successful another project. So a summary of our humble achievements to finish this one: 14 PhD completions, 13 masters, over 2.5 million external grants, 3 new labs, forming the Waikato Power Electronics Research Group, Viper, over 200 scholarly publications. In my 10 books, I have more than 4,000 printed pages. Many patents, collaborations with local and overseas industry, many workshops in many countries, tutorials, serving many editorial boards, chairing several international conferences, including International Conference on DC Microwaves 23 held in New Zealand, institutional fellowships, etc. So, in Elsevier SciVal data, for the subtopic supercapacitor ELDC and DC-DC converters, we are the world's leading research group. I'm very proud about this, giving all the credit to my PhD students. Thank you all, doing a great job. Okay, where did we share our expertise by delivering tutorials? Germany, France, Japan, China, Switzerland, Portugal, Estonia, Italy, Sri Lanka, India, Saudi Arabia, Bahrain, United Kingdom, and so on. So, in some countries, we have held multiple invited tutorials, particularly in the United States. Now, our industry relationships, Schneider Electric, North Carolina, USA, when I visited and gave them a lunchtime presentation to the senior engineers, they got surprised about our DC-powered, supercapacitor DC-powered appliances project. So, they are quite happy to work with us because my visit was coordinated by one of their advisory engineers, Dr. John Shear. Then, Transpower, I'm not sure whether my contact from Transpower is here or not, Steve Smith. So we run a Sustainable Energy and Power Systems course for the undergraduates and postgraduates, supported by Transpower, where 8 to 9 Transpower engineers are delivering visiting lectures. So this is a new course we began with the EEE program we started. Then, Worth Electronics Germany, EMC test labs. My PhD student is doing his tests inside the labs, totally free of charge. Then Fraunhofer Institute, Germany. Recently, when Chamara went to Switzerland, he visited Fraunhofer because DC Systems Group, Bernd Wander's group, they invited him to visit. Then other places, France's Ampere Labs in Lyon University. Then world's largest DC circuit breaker company, Sekiron, where I visited them. They visited us here. My PhD student was visiting them and showing them how to do certain things in supercapacitor applications and other things. We are establishing this collaboration now, but only thing is, unfortunately, I am a researcher. I have to work as the marketer also, which I can't do both. So, voluntary services to IEEE. I'm a contributing editor for book reviews for Electrical Insulation magazine, one of the oldest magazines of IEEE. So every other month, a book review done by me is published with my photo and the university logo. These are a couple of recent book reviews I did. So every other month, we tell about Waikato University and what we could do in these areas. Okay, so this opportunity has given me the opportunity to have a lot of latest published books free of charge. I asked for hard copies because I don't want to read things on the computer. I hate it, unfortunately. So they gave me hard copies. So my office is gradually getting filled with these free books coming. I'm going to put a separate library in our DC lab probably someday to keep these books for the benefit of everybody. So, my summary of 50 years, I believe that electronic circuit design is not necessarily a science. It is like an art. Because your brain's creativity, like a musician, artist, actor, you can work with circuits with creativity. You need to adjust your brain only, very little thing to do. If you master simple fundamentals to deal with voltage and current and the transistor with the flavor of creativity, you can do many things. You will enjoy every work day as an electronics engineer or a researcher. You don't feel you go to work. SCAR techniques and SCALOM theory, we believe that it can change the roadmap of sustainable energy systems because we believe in battery-less energy storage systems, BLESS. So we need to extend this success to multidisciplinary research for future success, future sustainability of the planet. I believe that no single discipline will solve the energy resilience alone. A good teamwork is necessary. So, in my 50-year journey with the roller coaster ride, my sincere thank you to first my beloved wife Priyani, then my two grown-up daughters, Dulsha and Malsha, and their husbands, Rajit and Kasun, and my 4 grandkids, Netuli, Mineli, Kavindu, Kavya, they keep us entertained. So, my division, school management, including Professor Jeff Holmes, Professor Mike Duke, former Dean Professor Brooks Classen, my former Deputy Dean Engineering Janice Swan, my head of division Professor Ilanko, and the entire staff for supporting me. My past and present students, my university and industry colleagues, my second supervisor of all my PhD projects, Professor Alistair Steinross, thank you for giving me the analytical support of every project of mine, sitting patiently with my PhD students. Our technical staff, our administrators, our industry collaborators, and fondly remembering my parents, my university teachers in Sri Lanka, my US mentor, my patron of the Clarke Institute, Arthur C. Clarke, who inspired me because none of them are living today to listen to me. So, thank you to my audience for listening to me about my life story. Thank you. So Mike will make a concluding remark, my dean. Thank you, Mike.
Well done, Nihal. Just a few remarks from myself. So first of all, I'd like to thank the staff, colleagues, whānau and guests for attending Nihal's professorial lecture this evening. And it's time to congratulate Nihal for becoming a professor and for all of the great work he's been doing in the School of Engineering. And I've only got 2 takeaways from this, really. The first one is what a great journey. I mean, your journey is amazing, from humble origins right the way through to being a professor at the University of Waikato. It's an awesome journey, very, very diverse. But the other one is, now we've got George from Thor Technologies here. It's the impact, the fact that you're not just doing research, but you're seeing your research being converted into actual products that people are using. It's called impact. So it's great that you're seeing that. And long may it continue with your team. But however, I know you probably have a lot of questions about Nihal supercapacitor and Skalom and all these very technical issues. So Nihal will be available afterwards in the foyer to ask any really gnarly technical questions that you should like to ask. With that, this now concludes the formal part of the evening, and we look forward to seeing you at the future professorial lectures. Thank you. Goodbye.
Thank you.
Well done.